In example 3, we have an absolute value problem, and it's asking us to do a definite integral. So technically, it's one of those problems where you have to do a yellow region / blue region and evaluate the problem separately. But we're not going to do that for this problem. We're just going to use the technology, the TI calculator, to get these solutions. It's just a lot less headaches if we can do it with the calculator. And it's actually very simple to use the calculator for this problem. You don't have to worry about plugging in weird values or anything. So let me show you what that looks like by converting the screen to a calculator screen. So first things first, I want to show you what the graph looks like so you know what you're dealing with. So let's go ahead and click on math, and we're going to go 1 to the right to find the first command, which is ABS. That's absolute value. So we're going to need to use that, and then we're going to type in the formula 3x minus 1. To close the absolute values, we just use another set of parentheses. That means that the calculator is now reading absolute value of 3x minus 2, absolute value. So now that's done, let's click on Zoom 6 to go back to standard window. And here's the graph. It looks like two different lines, one that's going down, then one's going up. So technically, when I find the integral from -1 all the way to 5, I should be doing two different, sets of integrals. Let me convert the window a little bit more one more time, and I'm gonna put, instead of y maximum and y minimum, let's put the numbers -2, and let's put, I don't know, 20 right there. That way we can see a better looking graph. So let's click second trace. Option number 7 is the integral, going from -1 all the way to 5. So this is the one I usually do in yellow. It's above the x-axis. This is the one I usually do in blue. It's also above the x-axis. So together, it seems like the total is 32.33712, whatever. So what you want to memorize is 32.33. But again, I don't like decimals. So this will not be something that you can plug into MyMathLab, for example. They want fractions all the time. So let's do the problem again on the main screen of your calculator. So again, the way it's going to work here is you're going to click math, go down to option number 9, and then now you need to type in the absolute value of 3x minus 2. So math again, move over to the right to get to the numbers, pick the very first option, 3x minus 2, close the parentheses. This means that the end of the absolute values is done. Now we're going to tell the calculator what letter we used, then what's the lower bound, then the upper bound. As you can see, it's the same number, sort of, like the one we saw on the previous screen. It was 32.33, but we want a fraction. So we're going to click math 1, and unfortunately in this case, it's not going to convert to a fraction. So I'm going to have to kind of work it out by hand, but this is the number I'm shooting for. To be able to do it, I need to figure out where to be able to do it by hand, I need to be able to figure out where the graph is basically turning around. What's the value right there at that location? That's what I need to get. Once I get that number, then I'll be able to do everything all over again with the calculator and get all the fractions everywhere. So to do this, to find where the graph is turning around, I'm going to grab the 3x minus 2 and make it equal to 0. When I do that, I get 3x equal to 2, which means x is going to be 2/3. This gives me the border value. This is where the graph is ending and another graph is starting. So let's test this. Is this actually right? So going back to the calculator screen, let me click on trace and then 2 divided by 3. That's the solution that I got when I looked for the border. And yep, there it is on the x-axis. When you plug in 2 over 3, which is 0.66, you get 0 at the end. So that means the following. That means that we're going to be able to do an integral going from -1 to the border value, which was 2/3. And then we're going to type in 3x minus 2 absolute values and everything else, plus another integral going from the border point, which is 2/3 again, all the way to 5. And again, absolute values of 3x minus 2. And now we're going to go to the TI calculator and plug each one of those integrals separately. And we're going to get the different solutions for each one of them. Okay. So basically what I did is I found a border point by taking the stuff that was inside of the absolute values and making it all equal to 0. So I took the stuff that was right there inside the absolute values and I made it equal to 0, and that gave me a border point. And somehow magically the calculator can now get the fraction for the first one, get the fraction for the second one, and I'll just need to add two fractions together. So let's see that in action. Again, I'm going to convert to the calculator and we're going to type each one of those integral separately, one at a time. So back to the calculator screen, here we go. So math 9 for the integral, then absolute values. So math move over once to get the absolute values, and then the command 3x minus 2. Close the absolute values, put the x, and the first integral started from -1 and it went all the way to the border, 2/3. And I'm gonna click math 1 at the end to make everything into a nice looking fraction. And there it is, like magic. Now this time it's not a decimal anymore. It converts it to a fraction for me. So the first fraction is 25/6. What about the second one? So again, math 9, and then absolute values, math 1, and then 3x minus 2 again, with the variable x, and this time from the border, 2/3, all the way to 5. And then again, math 1 to make it into a nice fraction. So 169/6. So the first fraction was 25/6. And the second fraction was 169/6. And so combining the two fractions together gives us the total that we're looking for. (97/3). So the total area is 97 divided by 3. And, you know, just for kicks and giggles, let's see what that looks like as a decimal. So what is 97 divided by 3 as a decimal? It's 33.333, which is exactly what we saw on the graph when we were doing the graph with the option number 7. That was the same exact number, 32.333. So, you know, calculators can be useful, but the only difficult part with these problems is getting the border point. So once you get the border point, it becomes very straightforward. So, and you get the border point by just taking the inside of the integral and setting it equal to 0, basically. So can you do the same thing for the next problem? So can you mimic the same steps down here for this new one? See if you can. Pause the video and see if you can get it done. Did you end up with 25/2? Okay, so the border point was 2x minus 1 equal to 0, which means x is 1/2. That's the border point. And again, I split my integral into two pieces. One that starts at -2 goes to 1/2. The other one goes from 1/2 to 3. And so it's kind of like pausing in the middle, taking a little break, and then doing the second integral. And I got the fractions for each one of them using the TI, and we got the 25/2 when we added two fractions. So that's pretty much how we work out these absolute value problems. There's a way to do it by hand, but it's just really annoying, and I just want to save you time and headaches. So that's why I'm telling you to use a calculator for these problems.